Okay, picking up where we left off on page 256, we're talking about the cooling options. And laptops are kind of limited, and so this little goofy thing that you can buy that fits under your laptop could help you keep it from smothering it. On page 257, we're kind of changing the subject radically, and we're talking about cloud computing. And there's an awful lot of benefits. Let's just kind of hit the highlights. And so, accessibility. I can get to my cloud version of my computer wherever I go. I mean, if I'm sitting at my home, I can get to my cloud computer. If I'm on vacation, I can get to my cloud computer. If I'm over at my friend's house, I can get to my... As long as there's an internet connection, I can always get to my cloud computer. There could be some cost savings because I don't have to physically have a server. In other words, I don't have to buy the hardware and the software and the maintenance and all the rest of the things. I don't have to pay for the electricity. I don't have to do any of that. And then, of course, there could be some space savings because, you know, a 19-inch rack or maybe just a computer, I mean, it's going to take up physical space. I mean, what if I just ran out of room? You know, I've got a server room that's just chock full of stuff, and I need one more server, and I'm thinking, oh, geez, it's going to be too hot in there. I don't have enough power. I don't have enough network connections. You know, it's just not physically practical to put yet another server in the server room. Well, cloud computing would be a good option. And scalability, which means I can have a cloud-based computer out there in the world and then just say, I plan on doing a lot of hard processing, so I need more memory and more CPU, but only for a week. And so you just contact them. Actually, you don't even need to contact them. You do it electronically. And you say, I want to add 2 more processors and add 8 more gig of RAM. And you go, boop. And now they're going to charge you a little bit more, but only for those days. So, I've got one. So this is a cloud computer for me. Let me see if I can... Okay, so now I'm running a Windows Server 2012 instance on the cloud. So I can do this from anywhere. I can go to my desktop. I can, you know, do all. I've got some development stuff out here, and no matter where I go, I can connect to a cloud-based computer. Now I don't physically own the computer. All I do is I pay a service that allows me to connect to this guy. Isn't that pretty cool? Okay, cloud computing. Alrighty, let's move on. On page 259, they talk about the data representation, and you've probably heard all these terms before about an analog signal versus a digital signal. And you know, radio wave would be like an analog signal. It's a kind of a wave, you know, like just like sound is analog. And computers don't deal with analog, therefore everything has to be converted to digital. So there used to be 2 different types of computers. You had analog computers and digital computers. There aren't any more analog computers that I know of. Everything is digital computers. Okay. So digital computers means that information is stored in a very dumb way. It's a bit. Okay, a bit just means a yes or no or a 1 or a 0. That's all it means. And the way it works is if I line up 8 of these bits in a row, it becomes a byte. And a byte is typically the smallest unit of measure, so to speak, that your computer can deal with. And you can string bytes together and make, you know, integers. You can string them together and make strings. You can string them together and make, you know, floating point numbers. But the bottom line is a byte is the typically the smallest as you can go. A bit is a piece of a byte, but you can't ask the computer for a bit. You have to ask it for the entire thing, and then you just look at part of it. Okay. I'm not going to go into too much detail like on page 260. They have a pretty cool description of, you know, what the letter E looks like and things of that nature. It's pretty cool, but I'm not going to go into that much detail. Let's just kind of skip a little bit of that and go to page 261 and talk about memory. You know, memory is it's the where the stuff is stored while your computer is working on it. So if I have a document I'm working, and so in Notepad, I fire up Notepad and I say open a document. My hard drive light comes on. It transfers the contents of that file into memory. So Notepad is only working on the stuff in memory. And then when I'm done and I hit save in Notepad, it hard drive light comes on again, and it sends it on back down. So memory is where things get done. I don't actually edit the file on the disk. I pull it off the disk, put it in memory, do my stuff with, and then put it back. Nothing gets processed at the hard drive. It all gets processed in main memory. Okay, so they talk about how, three basic categories of these items. They have the operating system and the programs. You have your application, and then of course the data that it's up. So Notepad itself, the application, Notepad the application, is running in memory. Well, the file is also in memory at the same time. So in memory is my operating system, because I can't do anything without an operating system. So I have an operating system, I have the application that I ran, and then I have that application's data all in memory at the same time. And of course it's all magic, and the machine can figure out who belongs to what. It's not that big a deal. They talk about how every spot in memory has a memory address, but I'm not going to go into too much of the details. When you're typically buying memory, you're buying memory in megabytes or gigabytes of data. If you have a typical machine these days, 4 gigabytes of RAM would probably be about typical, normal. Maybe if it was a tablet or something, it'd be smaller than that. But a laptop or desktop computer, 4 seems to be kind of like the smallest amount that you can get these days and still have a decent machine. They talk about, on the bottom of page 261, it talks about some types. They talk about the volatile memory. Volatile memory is, as soon as electricity goes out, you turn the machine off, well, then the contents of that memory is gone. The non-volatile memory, and there's all different kinds. Most of them are, it's called a ROM chip, which stands for read-only memory. It's a type of memory that is recorded in such a way that it can't be destroyed when the power goes out. It stays in there forever, and you use this on your motherboard. So when you first connect power to the motherboard, that part runs first. It pulls up and says, well, hang on, I just got some power. Let me check out what I am. Oh, wait, I'm a motherboard, and I've got this processor, and I'm going to do a little self-check here, and I'm going to find out where all the hard drives are. I'm going to pick the hard drive that has the operating system on it, and then I'm going to launch the operating system, and then I'm going to go to sleep. So that ROM chip has the beginning instructions, and of course that has to exist with the power being out, otherwise you'd never be able to turn your computer off, right? Okay, so non-volatile memory. I'm not going to go into too much detail. I kind of explained how memory and disk are kind of sort of related. There are some different types of memory. Again, I talked about how these are just some variations of traditional RAM, okay? And these are just kind of goofy terms. Don't get bogged down in the terms. That's not going to be on the test or anything. But you kind of sort of need to know a little bit about it. SD RAM and double data rate, and it just kind of went on. Second generation, third generation, fourth generation. RAM bus is hardly used anymore. It had a lot of legal issues, and there was lots of issues. I don't think anyone's using RAM bus anymore, but it's pretty cool stuff. So bottom line is, when you're purchasing RAM, if your motherboard is expecting DDR2, you're going to have to give it DDR2. If it was expecting DDR3 and you have some DDR2, you might think, oh, well, it'll be backwards compatible. No, it will not. It's designed specifically for that one type. Whatever type your motherboard it supports is the only type that you can use. That's basically the only takeaway from this graphic. Now, the RAM chips themselves, these things come in different flavors, and depending on, and see the spacing of the little contacts here, and how this is much closer together. So they used to be called like 72-pin memory modules, okay? Because you could count up the number of pins here, and that's how many pins there were. That kind of stuff. And nowadays they don't call them that. They call them, single inline module, SIM, or dual inline module. And once again, to prevent you from going nuts and absolutely destroying your system, this little notch right here, for example, is different for DDR2 and DDR3 and DDR4 to prevent you from accidentally plugging the wrong kind of memory into your motherboard. I guess you could do it with a sledgehammer, but outside of a sledgehammer, you physically can't fit them in the wrong place. And so a DIMM, a double inline module. Now, for laptops, they have to be physically smaller, and so they have another form factor called a SO-DIMM, and it's just folded in on itself, and so it's just maybe a tiny bit thicker, but it's physically smaller. Okay, let's continue. On page 265, we talk about memory cache. I mentioned that memory is out there, and my processor's over here, and so the processor says, "Hey, I need some stuff," and so it could be slow for the processor to talk directly to the memory. Although memory is pretty doggone good, it has not kept up with the speed of processors, not even close. So processors have, increased in speed by a factor of 10, and memory's increased in speed by a factor of 2. So processors can process a heck of a lot faster than memory. I mean, a lot faster. And so wouldn't it be kind of cool if we had some sort of a buffer in between the CPU and the slower RAM that kind of helps speed things along? And so you have some cache memory. Now, in the old days, you could get different types of cache memory. You could actually plug it into the motherboard itself. That's not the case now. The cache memory is inside the CPU chip. So when you buy the chip and plug it in, it contains 4 CPU cores, and then it contains different types of cache memory. And so you may have a processor that looks identical. Here's 4 cores at 3.2 gigahertz, and here's one with 4 cores and 3.2 gigahertz, but this one's $100 more. And you go, well, what's the difference? Well, this one has 4 meg of cache, and this one has 8 meg of cache, as an example. Okay, so the cache is now bound into the physical module, the CPU module that you buy. It plugs in. Okay. Towards the bottom of page 265, they talk about read-only memory again, we talked about, and firmware. Now, you've probably heard somebody talk about flash memory, and I've flashed the BIOS, or I've upgraded the operating system on my phone or my tablet by flashing the BIOS. And so those are just some cool terms, but what it basically means is, instead of having read-only memory that's set at the factory that never can be changed, well, they have a technique to make it mostly read-only. And so you go through this special gyration, and you can erase the contents of the memory and replace it with new memory, and then from then on, it'll stay in there with the power out. So you've been able to flash the read-only memory, which now it really isn't read-only anymore, right? Cool. Okay, so you talk about access time, how fast is the memory, and I mentioned that CPUs have gotten a heck of a lot faster than memory, so we're kind of behind the game, so to speak. On page 269, you talk about, we're done with memory now. Now we're talking about the peripheral cards that we plug in. So you may buy a system that comes with absolutely everything you want. It has a graphics processor, it's got audio, it's got everything. And so, you plug in your video card and your speakers and your keyboard and your mouse, and you're happy. And then one day you say, this game is a little too slow. I need a better graphics processor. So you go to the store and you buy a graphics card. Take it home, crack open your case, and plug this new card in. And if your motherboard already had a graphics processor, it's going to look at that and go, oh, I'm just going to go to sleep now. I understand you have a real graphics card, and so I'm assuming that's the one you want to use, so I'm just going to shut me down. There are newer versions that are smart enough to have multiple graphics cards running together, and you can hook up multiple monitors all over the place, because you could use one graphics card for low intensity things and one graphics card for high intensity things. Kind of cool. Okay, this is a good place to stop for the 15-minute mark. We'll pick this thing up again in just a few.